All right, in this lesson, we are going to talk about how to find key attributes of absolute value functions. And this requires using transformations. And so as a warm-up, if we are given this absolute value function, identify the following attributes. And so first thing I notice is that it is vertically stretched by 2. It is moved left 5 and down 4. So left 5 and down 4 is going to move our vertex to -5, -4. It starts at 0, 0, and left 5 down 4 would put us at -5, -4. Okay, and then that means the axis of symmetry is at x equals -5. The domain of an absolute value function is all real numbers all the time because it is a V. No matter what you do to it, it's going forever to the left, forever to the right. And then this function is opening up because there is no reflection. And so I know that the minimum is going to be at the vertex. And so the minimum value is -4. And so my range is going from that -4 to positive infinity. It's going up. Okay, and so we already talked about the vertex, the axis of symmetry, domain, and range. The new pieces today are going to be the intercepts and the absolute max and min we've talked about, but the new part will be the relative max and min on a given interval. Okay, and so here we have a graph, and so if you have the graph, that's going to help tremendously. And so if we don't have a graph, we are going to sketch a graph just so we can see what's going on. And so just from this graph, I see that the vertex is at 2, -2, which means my axis of symmetry is at x equals 2. This is the axis of symmetry. This is the vertex. Domain, all real numbers all the time. And then the range, it's going up from the vertex, and so -2 to positive infinity. Okay, the x-intercept is 1 and 3. So we write these as ordered pairs. It's a good habit to get into. 1, 0, 3, 0 are those ordered pairs. X-intercepts are x values when y is 0. Okay, and then our y-intercept is 0, 2. The y-intercept is a y value when x is 0. Okay. And so we have 2 x-intercepts because of the V shape. And then you'll always only have 1 y-intercept because it's a function and it passes the vertical line test. There is no absolute max because this function is going to positive infinity. You can say none, or D and E does not exist. And then the minimum value is the vertex, which we saw was at -2. So that is our absolute minimum. Okay, and so this next question asks for the relative min on 0 to 4. So they're restricting your domain. They're restricting your domain. And so if we just look from negative, or from the 0, x equals 0 to x equals 4, x equals 0 to x equals 4, draw in those vertical lines. Oh, that's not 4. we're only looking at the function between these two values. So when you're looking between those two values, you now have a maximum because we're not letting it go to infinity. And so the maximum value is now at 2. This is the highest the function gets on my interval. Okay, y equals 2 would be a maximum. And then my minimum is still where the vertex is. Okay, and so the maximum is 2 and the minimum is 0. Act like you're just taking a screenshot of just this part of the function when they restrict your interval. So restricting the interval to just this part and seeing where the function is. And so our maximum is at 2 and our minimum is at -2 because that's where the function is on that interval. Okay, if they change our max or our interval to -1 to 1.5, I'm going to clear my graph just so I have a clean slate to start with. -1 would be here. And then 1.5 would be here. That's where we're restricting it. Okay, and so I make the box where my function is. That's where I put the bottom and the top is where the function intersects with those yellow lines, those yellow vertical lines. So this is all we're looking at. This is our screenshot. And so my maximum is 4. And my minimum is -1. And so it's important to know where your vertex is on this interval. Sometimes it's the endpoints of your interval. Sometimes it's the vertex. And so that's why we're going to need to be sketching this. And so if we have an equation and don't have a graph, to find the x-intercept, you plug in 0 for y. And then you're going to have to solve for x. You're looking for the x value when y is 0. If you're looking for the y-intercept, you plug in 0 for x. You plug in 0 for whatever value you aren't after. And so when you're plugging in 0 for x, you really just have to simplify or number crunch, because that one's a little bit easier. You're looking for the y value when x is 0. Okay, and for the relative max and min on an interval, sketch the graph and the interval to determine which values to plug in. Okay, so here's our first example. We did this on the warm-up. It's left 5, down 4, so I know the vertex is -5, -4, which means the axis of symmetry is -5. Domain is all real numbers. It's opening up. And so that means the -4 is the absolute minimum. Okay, it's going up from -4. And so -4 to infinity. To find the x-intercept, we plug in 0 for y, which is the output. And so that gives me the equation 0 equals 2, absolute value, x plus 5 minus 4. Okay, and so to solve this, you have to first isolate the bars. And so anything outside these bars has to go. And so we're going to add 4 first because it's the number that's furthest away, giving me 4 equals 2 absolute value of x plus 5. Now you don't ever want to distribute the 2 into the bars. Now you divide by the 2 to get rid of it. And so now I have 2 equals absolute value of x plus 5. Now we're going to talk about this more in the next unit, but to solve an absolute value equation, you have to set the argument of the absolute value equal to the positive and negative output, because we talked about how the absolute value of 2 gives us 2, and the absolute value of negative 2 would also give us a 2. So if I just tell you the absolute value is 2, I don't know if x plus 5 was equal to 2 or negative 2. So we have to consider both cases. And so in this case, we subtract 5 and we get x equals negative 3. In this case, we subtract 5 and we get x equals negative 7. And so just like in our picture above, we had 2 x-intercepts. So usually you're going to have 2 x-intercepts unless your vertex is the one sitting on the x-axis. Okay, and so one x-intercept is negative 3, 0. Coming from here, and the other is negative 7, 0. Okay, and then for the y-intercept, we plug in 0 for x, which is a little bit easier. And so using my original equation, I'm plugging in 0 for x, so I have 2 absolute value, 0 plus 5 minus 4. So from here, we just number crunch. 0 plus 5 is just 5. Absolute value of 5 is just 5. 2 times 5 is 10. Minus 4 is 6. And so 0, 6 would be our y-intercept. Okay, and now we need to find the relative max and min on negative 9 to 0. So negative 9 to 1. So these are x values. Okay, and so negative 9, if this is my graph, I like to at least label where the vertex is. So just sketch some axes, and then negative 5, negative 4 is the vertex. So 1, 2, 3, 4, 5. There's negative 5. 1, 2, 3, 4. There's the vertex. And we know it's opening up. It doesn't matter how accurate the arms are, we just need a rough sketch. And so negative 9, negative 6, negative 7, negative 8, negative 9 would be out here. So graphing the negative 9, and then graphing the 1 would be over here. Okay, and so the reason why we wanted to graph this is because now we see that the vertex, it falls in between my yellow lines. If the vertex falls between your yellow lines, it's automatically your minimum or your maximum, depending which way it's opening. And then the maximum is going to occur at one of these endpoints. It's looking like it's going to occur over here at the right side of the endpoint, since here this other negative 4 is closer, but I tested both. And so the minimum is for sure negative 4. To find the maximum, we're going to test both the negative 9 and the 1 to see which one's higher. And so testing it means plugging it into the original equation. So my original equation is 2x plus 5 minus 4. I'm going to write that twice, 2x plus 5 minus 4, so that I can test both the negative 9 and test the 1. Okay, and so when I number crunch this, I get negative 9 plus 4, plus 5 is negative 4. absolute value of -4 is +4, which gives me 8 minus 4, which is 4. When I test the 1 plus 5 is 6. 2 times, absolute value of 6 is just 6. 2 times 6 is 12. Minus 4 is 8. So that's bigger. And so our maximum value is 8, which you can kind of see from the picture. At -9, we were closer to the vertex, and these y values are getting larger and larger and larger. So the further I get away from the vertex, the higher my output's going to be. And so this ended up being our max, and then of course the vertex is our absolute min, so it's also going to be our relative min if our interval, those yellow lines, if those intervals fall on each side of the vertex. Okay, example 2. I see a reflection across the x-axis, so I know it's opening upside down, and then it's been moved right 2. And so this vertex is now at 2, 0. It hasn't moved up or down, so the vertex is 2, 0, which means the axis of symmetry is at x equals 2. Domain is all real numbers all the time. And then this time, this 0 is our absolute max. And so that means our range is going from -infinity to 0 with a bracket. Okay, and so to find the x-intercept, we plug in 0 for x. And then we have to solve. And so first thing, this negative is technically a -1. And so our first step would be to divide by -1, and 0 divided by anything is still 0. And then remember, when we consider the cases, we would set it equal to the positive or negative, but positive or -0 is still 0. So the only case we have is that this x minus 2 equals 0, which means x equals 2. And so we only have one x-intercept this time, which makes sense, because if I were to graph this, it hasn't moved off the x-axis. It just moved right 2. And so only one x-intercept, and then it's opening down. And so whenever your vertex is on the x-axis, that's your only x-intercept. Okay, so for the y-intercept, we plug in 0 for the x and number crunch. So y equals negative absolute value of 0 minus 2, which is negative absolute value of -2. And then just the absolute value of -2 is positive 2. And so these negatives don't cancel. This negative gets taken care of by the bars, and then the negative outside is still there. And so my y-intercept is 0, -2, which makes sense according to my sketch. Okay, and so the interval we're looking at is -2 to 3. So -2 on the x-axis to 3. -2 to 3. Once again, I see the vertex is on the interval. And so that's going to be the maximum. If we're just looking at this picture, I see my maximum on this interval is 0. That's y equals 0. And then my minimum is probably going to be at this -2, because this 3 is closer. So this looks lower because it's further away. If you want, you can test them both. For the sake of time, I'm just going to plug in -2. And so we get our original equation. Since I know my minimum is at -2, negative absolute value of x minus 2, and we're plugging in -2. And so inside the bars, we need to evaluate that first. -2 minus -2 is -4. Absolute value of -4 is +4. And we still have that negative outside. And so that's going to be our minimum. Okay. Next, we do not have proper transformation form. And so when you see a scale factor on x, and there's no parentheses, add parentheses, and then divide this value by the number in front. And so in proper form, it would have an x minus 4. And you can use y equals instead of f. And so this function has been moved right 4 and up 9. So the vertex is 4, 9. Axis of symmetry is x equals 4. So to sketch that, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4, 9 is here. There's no reflections, and so the graph is opening up. Domain is all real numbers all the time. And then the range is going up from 9, so 9 to infinity. To find our x-intercept, we set the function equal to 0. So 2x, and you can do the simplified or the original. I'm going to go ahead and just do the original. Set that equal to 0. Subtract 9 from both sides first. And then when you see absolute value equal to a negative number, that's impossible. These bars only measure distance, which come out to a positive number. And so no solution. And it makes sense. If you look at our picture, it never crosses the x-axis. It's way up here. And so there is no x-intercept. For the y-intercept, there's always going to be a y-intercept. It's definitely going to be above 9. We can plug in 0 to see. And so I'm going to plug 0 into the original function. 2x minus 8 plus 9. And we're plugging in 0 for the x. 2 times 0 is 0. Subtract 8. Absolute value of -8 is +8. 8 plus 9 is 17. And so 0, 17 is way up there. Okay, and then our interval is going from x equals 2 to x equals 10. X equals 2 to x equals 10, which is way over here. Okay, and so looking at my picture, I know my minimum is the vertex. The minimum falls in my interval. The vertex falls in the interval, so that's my minimum. So 9 is the minimum. And then clearly this value way out here is going to be the maximum at x equals 10. Once again, you could plug in both endpoints to test. I'm just plugging in the 10 because it's so clearly the value for the maximum. Not the 10, but what we get from plugging in 10. So once again, using this original function, 2x minus 8 inside the bars plus 9, and we're plugging in the 10, which gives me 20 minus 8 inside the bars, which gives me 12 inside the bars. Absolute value of 12 is just 12. Add 9, we get 21. Okay, and then last one. It hasn't been moved left or right, but it's been moved down 3. And so 0, -3. This just tells us how skinny or wide this is, and we don't really care as we're trying to find these key features. So axis of symmetry is x equals 0. We have our vertex at 0, -3. No reflection, so it's still opening up. Domain, all real numbers all the time. Range is going from -3 to 0. To positive infinity. To find our x-intercept, we set the function equal to 0, plugging in 0 for the y. Sometimes I put it over here. I think in the last example I put it on the right. It's up to you. We would add 3 to both sides first and get 1/2 absolute value of x equals 3. And then to get rid of this 1/2, we can multiply both sides by 2. That's better than dividing by 1/2. It's the same thing. And so we end up with absolute value of x equals 6. Well, if the absolute value of x is 6, that means x was either -6 or +6. Because when you take the absolute value of -6, you get 6. When you take the absolute value of +6, you get 6. And so we have 2 x-intercepts, -6 and 6. And you can kind of see the symmetry of this graph. And then our y-intercept, we plug in 0 for the x and solve for the y. And so I would get 1/2 absolute value of 0 minus 3. Absolute value of 0 is 0 times 1/2 is still 0. And so -3, which makes sense. That's our vertex. And then now we are finding the max and min on the interval from x equals -10 to x equals 1. So remember, these are always your x values, and we're trying to find the y's. So x equals -10 would be out here. X equals 1 would be right here. Okay, and so once again, our vertex falls in the interval, and so that's definitely my minimum. And then the maximum happens at the end point, and it's going to be the end point that's furthest away. And so this is clearly further away from the vertex, so that is going to be our maximum. And so we already know that the minimum is -3. To find the maximum, we need to plug in that -10. Okay, so go to your original equation, y equals 1/2 absolute value of x minus 3, and we're putting in this -10. Absolute value of -10 is +10. 1/2 times 10 is 5, minus 3 is 2. Clearly not drawn to scale, but that would be our 2.